Hello everyone, welcome back to our Knowledge webinar series. In this week's episode, SkySieve new cloud-based structural analysis software. Join us for a demo of the range of software and features of SkySieve. SkySieve is completely online, so there's no need to download, install, or update your software. Watch as Sam Carigliano will demonstrate the clean, easy, and fast analysis tools of SkySieve, including SkySieve BIM, Shaft, and Structural 3D. Today's presenter, Sam Carigliano, is the CEO of SkySieve Engineering. Sam co-founded SkySieve.
So this is our homepage here, so I've just landed on skysieve.com. And to get access, it's just a matter of logging in through any web browser. So I'm on a Mac and I'm using Chrome. We recommend Chrome or Firefox. And it's just a matter of logging in here. And that will give you access to everything. So no installation, no maintenance, it's fully cloud-based. So that was pretty much our whole installation, maintenance, onboarding experience was just in that login. So you can access it from any computer you're on, from anywhere in the world, and all your files and software are all stored in this one location. So here you get landed on our dashboard. So we have a file manager. We have a list of different software just running down here on the left. Today I'll be taking you through a BIM and Structural 3D. They're our two most popular products, and they are available on the one account, which is the SkySieve professional account. So here we have a list of our software. You can toggle that in now. And here we have a list of all the files that we have through our file manager. We have like a public user file, so you can actually see what other people are building. It's just like an ongoing list of what users are creating. So you can see some really cool structures in there. Otherwise, we do also have just some structural samples just to get you started. You're looking at what's possible on the SkySieve software. And this is obviously all cloud-based, so all your files are managed here on our servers. You can send them to other SkySieve users. It's a fully functional file manager, so you create folders, subfolders, copy, paste, rename, you name it. You have a fully, you can have a fully manageable file manager here. At the top we've also got some support. We've got FAQ, documentation, contact us, and we really pride ourselves on our service. So we generally get back to you within a few hours and really try to help you with your modeling analysis needs. So we're not just a software, we really want to give you guys the best services we possibly can. So we really are hands-on. You'll be speaking to an engineer or a developer and someone who's actually created the product, and they can really give you a really good customer service. We also have our account settings, upgrade page, and obviously log out. So without any further ado, I'll take you through an example of a BIM, the BIM software use, and also Structural 3D. So starting with the BIM, I'll just click this side tab, and this will take me to the BIM software. And we get a lot of feedback that it's a really easy user interface. So it's very intuitive. It won't take you too long to learn how to use a product. We find with SkySieve BIM, it's a training of watching a 10-minute video or a demonstration like this, and you're pretty much fully trained up in how to use the software. So I'll just start by first adding a beam. So I'll go to Imperial because I'm sure most of us are based on the Imperial system. So I've just changed my force units here just by this little drop-down menu and the length just here. So now when I add a beam, I can add it at 10 feet. And add my support. So I might add a pin support at 0. Actually, I might add a fixed point at 0. And a roller point sort of 3/4 of the way along the beam. Then I can add some point loads. So you can also angle your point loads. So I'll just do angle there. And I might do this at the end of the beam. So you just enter your position, the magnitude, and the angle at which you want to assign that load at. And distributed load, so I'll do maybe 2 to 8 feet and 2 to 5 kip feet in the downward. So I can go upward force or downward force. I'll just leave it as a downward force for now. We've also made it really easy to make changes, so maybe we want to change that location. I can just go down here to my table where I have all my inputs here, and I can just change that point load, and maybe I'll move it across a little bit to 9 feet. So just enables you to make changes really, really quickly, and especially when you're iterating between the results and the model setup, you can just hit that edit button there, and it makes it really easy for you. You also see that the loads are all proportioned to the largest load, so we've got 5 kip feet, down to 2 kip feet, down to 2 kip feet, and it's all proportional, so you can really see where the main loads are occurring at. The last thing to do is just assign a section property to that beam. So I'll just click this Add Edit Section, and here we have our section builder. So this is kind of constant throughout all of our software, and so once you've learned it once, you know how to use it for SkySieve Beam, for Structural 3D, and all the software that you have available to you. We do have a library of sections, so being in the American, we'll go through American library, so we do have American, Australian, British, European, and you can also save and load your own sections. So I'll show you how that can be done in just a minute. So I'll just start by loading an American AISC W shape, which is sort of your traditional I-beam. So when I double click that, I can see it's loaded. I can see my section properties here and also my material properties here. And I'll calculate and submit. And I can see it's updated there. So now I have my beam section information and that's ready to go. So as you can see, I was talking and explaining, but I managed to build that structure. Well, I can build that structure within 30 seconds or a minute. So it really allows you to get started really quickly. You can run quick analysis, quick design checks, or preliminary designs, just in a matter of seconds, really. And I might just add a hinge just to show. I'll add that on 3. So you can do hinge joints here. Yeah, just more functionality for your designs. So once that's done, I'll just hit solve. I'm happy with how my model's looking, and I'll just hit solve. And here we get taken to what's like a very simple, a very clean, concise report of the results that we have. So here we have our free body diagram. A great feature is you can turn on equivalent loads, so you can see where those equivalent loads are sort of acting. Turn that on and off. I do also have my results here, my reactions, sorry. So I have my bending moment of 20.7 kip feet, my X and Y components of that fixed support, and also the roller support that I had here at this location. Another great feature that we found we didn't like with traditional software is a lot of times this could get cluttered up and you can't really see some of the results. You'll notice that all of our labels, you can actually drag and drop them so you can really see what's going on there. So you never get that clutter where you can't really tell what's going on. We do have the full working solution of the reaction forces. So here it'll tell us exactly how we calculated those reactions. So for a lot of engineers, they need to actually hand calculate or verify their logic. This allows them to do so and check their answers and check that their logic's correct and that their hand calculations are exactly right as well. And it's good for students as well for learning. It shows how we got to the solutions that we got to, and it works for determinate beams. So I'll just close that. Here we have our beam section results. So we have the same thing as a section builder. We've got all our results here, so you have a summary or a record of what you've built as your cross section, and your dimensions here on the left. Here we have our shear force diagram. So we have nice clean diagrams, and you can sort of, again, you can move these results, move these numbers, and so if there's any ones overlapping, it's just a matter of moving these out. You can also determine the shear force across any point. So say we need to know what it is at the midspan. I can put in 5 feet and it'll tell me the exact shear force at that location. So I can see it's minus 0.97 kip. We've also got the shear force equations here, so you can plug them into Excel or plug them into whatever other thing that you need to calculate. We have all the shear force equations at any span across the member. We can turn on the full working solution here. Again, so we can work out the cuts at each location. So we can see whenever there's a change, like there's a load or a support, it will create a new equation, and this shows you how we came to those equations. Same goes with the bending moment diagram. So obviously these take a lot of time to hand calculate. So in a matter of seconds you can get a nice clean diagram that you can include in your reporting. Again, if I want to see what's going on at 2, I can put it in 2 feet and it'll tell me what's going on there. Next would be the vertical deflection. So we can see there's a hinge joint, so there's a bit of a kink in the deflection curve, but it will tell us the max and mins of each span. So I can see here we have a maximum of 0.02 inches. And we've also got it tabulated here, so you can just easily identify where the maximum locations are and what the maximum deflection here is. Again, might want to see what it is at the midspan, and we can see our results along the span of the beam. Rotational displacement works in the same way, so it's just tabulated form, so we can see what the max and min rotations are. And finally, we do have a really cool 3D renderer. So this is it enables you to really see it in 3D life. You can make sure that your structure's been built correctly, that the dimensions you've entered all make sense. You might see it's too slender, but this enables you to really visualize how the structure looks in 3D space. So, and a really great feature is you can actually turn on the specific results of what you're looking at. So say this is bending moment. I've also got shear force, I've got deflection. I can select from this menu all my results and it'll show it in real life on the 3D renderer. So I'll put that as deflection, and I'll also show that you can actually deflect the structure. So I can see now my hinge joint is really, there's quite an excessive sort of change there in deflection. And I can really visualize and put that into perspective and include in my reporting. So anyone who looks at it can now see, okay, we have a maximum deflection here in the blue of minus 0.028 inches here, and that's where it's occurring, and I can see it's a hinge joint. And it really it puts a more real-life perspective on the structure rather than just looking at a simple diagram. And I'll leave it like that, so when I include it in my report, that's how it's going to show. And finally, we have a stress result profile. So this gives us our max and mins of our shear stress and bending stress. So I can see immediately where my maximum stresses are occurring. So I can see that one's occurring at 7 feet along, where there was a support. I can see that my max shear force, shear stress is there, almost 4,000 psi. So for toggling between analysis and results, I can just scroll down to this table, the stress result table, and immediately identify where my stress areas, the stress concentrations are, and where I need to really focus my design on. I can even look at points along the beam, and it's going to tell me what the stresses are at that location. So I can really use this in sort of with complements with this, and go down to bending stress, and just have a look at these key areas that I need to look at, and it'll show me a stress profile of what the stresses are doing across that cross-section. And just to show you how quick, so that's the whole report there, and just to show you how quick you can iterate, and I'll just hit return, and maybe I'll change my cross-section. So I might make this top flange a little thicker, so I'll just put that up to, say, 8. Calculate, submit, so I can see it's gone thicker. Solve again. and my results are ready to go. I can scroll straight down to my stress profile and say, okay, that's gone down a little bit. I'm happy with that design. Let's export this report for the engineer or for the colleague or whoever it is that you'll be sending this report to. So from there I can save to image. We also have a save to PDF function that will be released in our latest update, but I'll just show you the save to image one. And this will just create a nice clean document for you to print or include in your reporting, and you can download that at any time. So on the return, so another thing you might want to do is just save and load your structure. So I'll save this for later use. And that's now stored in my file on the cloud. So if I jump on another computer or if I want to show a colleague and I'm at their office, I can just simply jump onto Chrome, log in, and load my beam from just there. So it's nice and easy and it's all accessible. So I think that's pretty much it for SkySieve Beam. If there's any questions, I'm happy to address them now. But if not, I'll continue through to Structural 3D and we can answer all the questions at the end.
Yes, Sam. Can you save locally to your own computer? That's the question.
Not at this stage because the SkySieve Beam file isn't compatible with any other software. It's just a 1D structure. But for Structural 3D you can.
Okay, because the follow-up to this question is often in the field I don't have Wi-Fi access, so how do I address this problem?
Yeah, sure. Okay, so you can use your hotspot. So I've used my mobile hotspot at times. You just turn that on and it'll give your computer Wi-Fi access. Yeah, that's usually how most people would use this remotely out in the field. Or it works on iPads, so if you have an iPad with internet connection, that's what a lot of people use as well.
Okay, thank you, Sam.
Yeah. Okay, so I'll just go through to my Structural 3D program. So we actually have a truss and frame program, but they're identical to Structural 3D, just with some limitations. So I'll just take you straight through to Structural 3D. Just make sure my internet connection is okay. Can you still hear me, Barbara?
Yes, I can still hear you. We're just waiting for the connection.
Okay, I was just worried my internet dropped out.
There you go.
Here we go. So here's our interface of the Structural 3D program. So as I mentioned before, what we really like to promote is just it's simple, it's easy to use, it's clear, it's intuitive, so you can really get started immediately without any training whatsoever. So people will sign up for our accounts and jump straight in with virtually no training. If you do need training, it's just a matter of watching this 30-minute video or hour video. But it really is, the way we've designed it is to make it really intuitive and easy to use. So on our left here we have our model building features, so adding nodes, members, etc. At the top we have our toolbar. So you can start a new file, you can open existing file, save load, and import and export. So with that question, we can export as a DXF file, so you can save that locally. You can send that to architects. It's interchangeable with other software, so you can really import and export your structures. Under edit we have undo and redo. Job cleanup, I'll go through that a little bit later. Data sheet we'll also go through later. Output, and I'll just show you the settings just now. So here we have all our settings. I will change that to Imperial again, so it's just catering to you guys what you normally use. And we also have some visibility settings, some view settings, like you can turn on perspective or orthographic view, and some solver settings, so you can really be specific about how accurate you want your results to be. what FEM elements you're using, etc. So I'll just save that as Imperial. And on the right we have our view settings, which I'll go through as I'm building our model. So as we would start normally, we would add nodes. So nodes are going to be the start and end of any member that we build. So with any job, we'll start with assigning some nodes in 3D space. So it's just a matter of entering our XY position. And for today, I'll just do a simple beam. So I can just toggle by hitting enter and entering my numbers. And I'll make like a slender sort of frame. So as I'm entering, you can see it's updating. And I can actually rotate and change. Now another great feature is I can actually add in through my data sheet, I can actually copy and paste these nodes. So I can do things much quicker. Well, I'll just go ahead and copy that and paste it and just add some Z component to it. And now when I apply that, it's just added that in. And I can even, it works much like Excel spreadsheet, so if I enter a 4 there and I want to make a mass change, I can just drag and drop that, hit apply. So if you're working on a really big structure, this just enables you to make mass changes in a matter of seconds. So that's all my nodes there. And again, going with ease of use, we can now join these up as being members just by dragging and dropping. So you can really mock up a design really, really quickly just by dragging and dropping your members between your nodes. Alternatively, you can go through our side menu here and hit members and just join them up, 8 to 6, nodes 8 to 6, 7 to 5, and 4 to 2. So it's just as quick. I can just toggle through and mock up our design. Here on our members section, you can assign section IDs, which I'll show you now. Say for this top part, there might be a different section. I'll just change, sorry, I'll select the member that I want to change, and I'll just change that to being 2. So I can really click and toggle on, assign different section properties really, really quickly just by clicking the member and changing the properties. I can also angle it, or I can also change the node fixity. So I might want to put a hinge joint at 8 there, so or maybe at 3 here. So if I go 5, I'll change the fixity to a hinge joint there, and I'll also change the section properties to 2 and hit apply. And we put a little tab there, just a little line there, just to show you that that's not a fixed support, that there is a hinge joint there. So I'll go back, and now I'll assign some section properties. So we've added these members. There's 2 different types of sections. I can see here section 1 is not defined and section 2 is not defined. I can click here and it'll open that menu, or I can just hit the sections button here, and I can start assigning my materials and my members and my sections. So I'll just enter our SkySieve builder, and again I'll just import some sections from our section library.
Sam, I have a question. Sam, I'm sorry to interrupt. Sure. Barbara is asking, can you please open up the spreadsheet view for the members too?
Yeah, sure.
Thank you.
So there we have our max changes as well. So if you want to say assign, maybe we want to change this to 3, yeah, we can just simply click that and drag. So there is a data section for all of our functions here. So it's asking me I'll discard any changes I made. So for supports, there's a data sheet. For everything, there's a data sheet. Point loads. So if that's what you prefer working with, they're all available there. Okay, so I'll continue through. So I had to set after I set my first section, I can see there, now that's updated, so I can see a little I-beam, and I can immediately identify what that grey or that black section represents. And I'll just add a second section for the top. And this one I'll actually just do manually, so I'll add a rectangular section. Maybe make it a bit bigger. So I can make my custom section and add that, and as see, it's recognizing it there again. So now my sections are assigned. I'll just add my supports here at the base. And a really great quick feature that you can do is you can actually just comma separate these, so I can go 1, 2, 5, and 6. Assign my restraint code as being fixed, so I can select any of these options or put in a custom code, but for my purposes I'll leave them as fixed and just hit apply. So in a matter of seconds my support, I've assigned my boundary conditions or my supports to my structure, and I can see now that my base is being restrained in fixed supports. And so now we just have to apply some loads. So I'll start by applying a point load. Point loads can be made at nodes or midspan or any point along a member. So I'll add one at node 4. I can see node 4 there on my diagram. And I'll just do something like that. So something in the X and something in the Y. And there I can see that it's showing my, my force there in the X and Y component. I will also assign a distributed load, maybe across this member 3. So I'll just assign member 3, and it's asking me for my start and end magnitudes. So I'll just do like a distributed load 2 to -5. And I'll offset this from the start and end position. So 20% from the start of this node and 20% from this start of this and the end of this node. And I can also assign load groups. So if I want to do load combinations, maybe this is a live load and this one's a dead load, I will assign load group 1 there. So it's a different load group. I'm assigning this UDL, this distributed load, as having a different load group to this first type. So I hit apply, and I think I've made a mistake in what I was entering. Yeah, sorry. So -2 in the Y and -5 ending in the Y. So now I can see again. Again, everything is proportionate, so I can see 2 to 5, so I can see I've entered that correctly. I can even scale these loads, so you know, by holding S and scrolling, I can easily scale these loads just to make them more visible or make more sense of it. And that's pretty much it. I mean, I'll assign a self-weight to the structure just to show you how easily that can be done. So gravity in the Y. And I'll just show you a bit about the load combinations. So if I want to turn on the load combinations, I can see group 0 is this one, so maybe I want to apply a factor of 1.2, and this one here is I want to maybe apply a factor of 1.5 to this distributed load. So I can apply that, and I can see it's updated in my console there. And I can see my self-weight is now turned on, and my load combination, that's the equation that I'll be using. And I'll just show you how quickly it is to edit. So I mean, my structure is completely built. I'm happy with my model. I'll be ready to solve, but I just might want to make a few changes. As I mentioned before, you can click anything. So I can click my loads and change those there. I can maybe I want to drop this load node a little bit, the Y component. So I'll drop that to 5, and you can see that that's immediate. Those changes made immediately, and now I have the structure, the adjusted structure that I wanted to, just by clicking and making the changes through our left menu here. But that structure is completely ready. I'm happy with how I've built that. You can see, again, I was talking my way through it, but something like this would typically take me 2 minutes to generate. So really, really good if you want to do like a rough calculation or a preliminary design, or you just want to be able to build things quickly and analyze them really, really quickly, then yeah, this software we really designed it in that way where you can build it really quickly. But without any further ado, I'll go ahead and solve the structure. We have 3 analysis available, so linear static, linear static and buckling, and a P delta. I will do a linear static and buckling analysis. And so this will get sent off to our server. Our server will do all the computation, so it doesn't put any strain on your computer at all. And you can see our structure is ready to view the results. So the buttons here on the left obviously have changed to account for the results that we have, and the structure is grayed out just to make everything a little bit more clearer. So I'll start with reactions. So here we have our reactions. Obviously all our supports are at the base, And you can toggle on the different results that you want to look at. Maybe I just want to focus on the moments, because what we found with a lot of other software is this would be very cluttered and you wouldn't be able to really see your results. This diagram's not too bad, but in more complicated structures it can be. So being able to toggle on different results just enables you to view really zone in and look at the specific results that you're interested in. So that's reactions. Shear force diagrams. So we can see that's kind of, it's a clear way to view the shear force diagrams. We can scale these, so we can scale up or down based on what we want to look at. And again, we didn't like traditional software because it had this cluttering of results here. So what we've done is we've added a few extra features, one of which being you can actually select a single member and you can really isolate that member, so you're not confused with the diagrams of all the other areas. This just allows you to select that one member and view those results. Another feature we've added, so I can turn that on and off, is again being able to click and drag these results, so I can move these around and really see what's going on in case there's any clutter of information. And what I might do here is I'll just actually save my structure. And the reason I'm doing this is I'm going to make screenshots along the way, and they'll get saved with my file. So say this member is a really crucial part of the design. What I might do is basically, oops, sorry, let's put that. And that's a part of my design that I want to include in my report. I'll actually screenshot that and say shear force diagram member. So I'll screenshot it, it'll save it locally on my computer, but it'll also store it with my file on the cloud. So now I'll have a screenshot available in my, my camera roll, and I'll be able to include that in my reporting. So it's actually asking me, do you want to open your camera roll here? So here I can see my camera roll of all my screenshots that I've taken throughout the demonstration, plus the thumbnail of my structure, just how it looks. And I can, at any point, I can download these, I can delete them, however I please. So I'll just close that for now and continue with the demonstration, but you'll see how that comes in handy a little bit later. I can also look at shear in the Z, or sort of toggle between Z and Y. So you'll see whenever you open up a result, you'll have these options available to what plane you want to focus on. Onto moments, so here we have our bending moments. Again, we can turn these on, or we can control and drag and turn on a few results, just if you want to look at those ones. But it works much in the same way that shear force did. Axial diagrams, we've actually done a little bit different, just to make everything a little bit clearer. So I can see exactly what's going on, just at a glimpse. I can look at it, I can see what's going on. So I can see most of my members are actually in compression, and I just have one tensile member here at 0.21 kip. Again, we've done this just to make everything a bit clearer and easily identifiable. I can turn on the normal diagrams if I want to look at the traditional way, or if there is some like changes in the axial. Sometimes axial aren't exactly the same throughout a whole member. This will allow you to visualize that. Displacement of our structure. So here we have the deflected result, and you can scale in and out. So you can do this by using this, or by holding S and scrolling, and I can see how my structure is deflecting. I can turn on, say I just want to focus on the sum. I can just turn that on through the side menu. That's pretty straightforward. And then we have all our stress profiles, so we can turn on the different stress results that we want to look at. Might scale that down a little bit and look at the different, we have top bending stress, bottom bending stress, shear, axial, and combined stresses as well, all available in that side menu. The next result would be buckling analysis. So this is telling me here that the structure has a load factor of 294, which is less than 1, so there's actually no buckling occurring in the structure. So if I was, there would be, say this member here was buckling, there would be it would be denoted by a red line. So this line would end up red, and it would be in the buckling shape. So it might be kicking out like that. and it just allows you easily identify what members are buckling or at risk of buckling, and make you adjust your design, allow you to adjust your design accordingly. I'll come back to analysis report. I want to add some more screenshots into that. But again, we have another great feature, which is our single member feature. So I can actually turn on the bending moment results, but say I want to focus on a single member, I can actually click that member again, so I can click that member to isolate it, or I can include it here and it will actually show the specific diagram, which I can then save or copy that image. So it allows you, if you want to include these sort of things in your reports, you know, if that's a real specific, actually I think I got the number wrong, it's member 3. If I want to include that specific result in my diagrams, it just allows them to do it in a really, really clean fashion where people can easily identify what's going on in that member. I can actually toggle on throughout in between to get the results in between to get that maximum 1.5. The bending moment there is 2.58. But I've also got my max and min results here. And I can change the results. So maybe I want to look at the shear force in the Y. It'll update and make those changes. So you can go through a specific member and view the results for that particular member on a nice grid plane. So I'll go ahead and turn that off for now. One thing I didn't mention is you can actually do that along any of these diagrams. So if I, again, focusing on this one member, I can actually view the results throughout the member. So I can see 2.5 is where the maximum is for that particular member. So that's all my results. I'll show another way to display the information. So what we have is actually a 3D renderer. So it brings the structure to life much like Beam, and enables you to view the structure in a real life application, and we can see that that's going to be a really strong structure. We've built some really large sections, and I can turn a base on and really bring it to life, so I can include this in my reporting. And a really great feature is we actually have our results, so you can turn on your results for any of the results that you've seen in the previous page. Maybe I'll look at deflection or bending stress, and I can see exactly what's going on in my member there. I can easily identify where the main areas of the design are through this color contour, and I can deflect my structure to bring it to life. And what I'll do is I will take a screenshot of that. So BMD render, and I'm going to include that in my report. And I can, so I can animate that just by clicking this play button, and it'll animate that. I'll turn that results off, but it just allows you. We find it allows you to. It's just telling me that my screenshot's been confirmed. It just allows you to easily identify the main area. So I can see that's where the main deflection is occurring, or maybe I want to look at the bending stress in the Z. I can see that there's some bending stress here, but the most of it is occurring here in this top member, in that joint there. So I'm happy with that. I've looked at my design. I'll go back, and now I can demonstrate how we can analyze. We can export an analysis report, taking all the screenshots that we've done throughout the structure. So I'll just click analysis report, and it's going to ask me to select images for reporting. So I'll include the BMD render and the SFD member, so I can actually click which screenshots I'd like to include, and then I'll just hit Save PDF. So what this will do is generate a nice, clean PDF format for my my analysis report. It's got an example. It's got the screenshot of my structure, so I can immediately identify what's happening, what structure I'm looking at. It's got my file name. If I assigned any job names or designer, if I, say I have this account for a number of people, I can actually assign a designer, so I know who actually built this model, and any job descriptions that go along with it. So this is a job setup, so it'll tell you exactly how you've set up your structure, so you can pass this on to another engineer and they can make sure that all the input is correct. I'll scroll down. I have my supports, my loadings, my section properties, all the typical information that you need to know for an analysis report. But here we do have our user-defined screenshot, so you can actually pass on more information to the engineer. So say this is a critical design, critical part of the design, that member, I can include a whole range of screenshots. So my manager or my colleague or my client can easily see what's happening and what I'm talking about. I don't have to sift through pages of numbers to view the results that I need to. I can actually look at these in my report in a nice, clean, concise manner. And then we have all our sort of node reactions. We have all our specific results that you might want to export and view the in like Excel spreadsheet or view specifically for the points along a member. Yeah, so full analysis report available in PDF format. And that's pretty much it. I can save my structure again. So I'll just save that just to make sure that I have the most up-to-date version available. And I think that's pretty much it. I hope I haven't forgotten anything, but if you have any questions, I'd be happy to address those, and I think that will open up any other features and functionality that we do have available. So I'll just show you actually how that's come into my dashboard. So if I go back to home, I can now see that under my structural 3D, my NoVeg demo is actually there. So I can now share that. If I had, for instance, Barbara at NoVeg, I'm not sure what her username is though, so it's probably not going to go through, but I could just send that to her and she will get that into her inbox in her file. So you can really, it allows you to exchange information with other SkySoup users really, really easily. So if you did roll this out for your office, we can set up shared folders where I save this and Barbara would be able to see this file as well. And then she could just simply double click it and open it up in her software and be able to make changes quickly from wherever she is. So it's really unleashing the power of the cloud software. So if there's anything else, I'd like to probably use this time now to address any questions.
No questions so far, but that was very cool, Sam. And yes, please, if you have questions, this is your chance. Yeah, we'll be waiting a few seconds. And also there's, yes.
Sorry, go on.
Yes, I just see a question. Does it also perform truss design?
It does. You can build trusses in it, but it's all analysis. So it's just a structural analysis. So there's no real design components to it. But yeah, trusses are just a matter of going into members, and you can assign, say, this member as being a truss member, and changing those fixities manually, and then hitting apply. And I can see now that it has a hinge joint at both ends, just denoted by that little tabs there. So a lot of people do use this for truss analysis or bridge analysis, and then they use those results to then proceed with the design.
All right. Yeah, no, I don't see any more questions. But I wanted to say something about a surprise for our viewers today. If you want to email me at barbara@noveg.com, I think Sam will be happy to set you up with a free 1-month trial. So keep it in mind, barbara@noveg.com, refer this webinar number 208, and we'll be happy to let you play with it for a month free of charge. And also, another question, Sam, can you analyze concrete too?
You can change the member property, the section property materials. So for, say, section 2, we want to make that concrete. I'll just go into my builder, and I have a whole list of materials available here. So I can go concrete, and I can actually put in my manually add, so say that's not right, say it's a stronger concrete. My Young's modulus there of 3000 KSI, my density and my Poisson's ratio, I can actually make those changes to make a custom material, calculate and submit, and now those members are concrete members. So yeah, you can pretty much model any material that you like
Okay,
with
and
this.
what about plates?
Plates is something on our features list, our future features list, so it will be rolled out in the next coming months. With our software, we're always adding to it, and these updates happen really quickly. We update every 2 weeks, and so adding features constantly, and when they do occur, you don't have to worry about upgrading, you don't have to worry about updating, it'll just come immediately. So Plates is definitely on our future work list and should be out in the next 3 months or so.
This is awesome news. Okay,
Yeah.
yeah. Last
Yeah.
chance
And
for
we
you
love the
guys.
feedback.
Any more questions? Yes, how does the concrete beam design address steel reinforcing rods?
Okay, so that's actually something we're working on right now. So that's one of our features that we'll be adding is composite sections. So at the moment, you'll just assign a single member with a single material property, but we'll be adding like steel or composite sections, so you can add in your steel reinforcement. That one, we've started work on that already, so that one should be out sooner rather than later. And we're also just completely beefing up our section builder to account for completely custom sections, composite sections, importing DXF files as your sections, and just really unlocking a whole great list of new features in the section builder. So yeah, to answer your question, it doesn't do it at the moment, but it is coming out soon.
Good news. All right.
Yeah.
If that was it, I will take the screen back and wrap it up. And I want to thank everybody for attending the presentation. Let me see. Okay, here's where you can find SkySafe on the Noveg webpage at noveg.com. Visit us and check it out. You can email me, barbara@noveg.com, for a free 1-month trial. And also for informations on any other specials or new releases in our catalog, join the Noveg Network on Facebook, Google+, or Twitter. And don't forget, the next week webinar is about rapid 3D fabrication with Vectorworks subdivision modeling. And to rewatch today's webinar or previous ones, check out our Noveg YouTube and Vimeo channels. Our webinar playlists as webinars for every software taste. Thanks again for joining us, and thank you so much, Sam, for waking up so early for us and a great demo. And looking forward to have you email me, and looking forward to, talk to you more and have more webinars with you, Sam. That was a real pleasure.
Yeah. No, I definitely look forward to it, and thanks for having us.
Okay. Bye-bye, everybody. Have a great day.
You too. Bye.